All right, let's take a look at this fan box problem. So before we even begin, look carefully about which way the fan is facing. It's very confusing because the box is moving to the right, but the fan is trying to push the box to the left based on the way it's facing. And it says so in here, it says, as the box slides up the ramp, the fan exerts a force opposite the direction of the box's motion. Well, what's the box's motion? The box's motion is up the ramp like so. So this is the direction of motion. Well, let's model all the forces on the box. The question says, what is the total work done on the box as it slides up the ramp? There's no mention of the Earth at all. So if there isn't, then we cannot assume that the Earth is part of the system. We'll have to assume we're just modeling the system as the box itself. Everything other than the box is external to the box. So if the box is on the ramp, here it is. Let's draw all the forces. So there's going to be a normal force perpendicular to the ramp, right? There's going to be a fan force. Well, it says the fan force is opposite the direction of motion. That means the fan is trying to push the block this way, okay? And then we have gravity going straight down. So I'm going to draw that a little bit larger on the side. So again, we've got mg going down, right? Always. We have the normal force acting this way, Fn. And then we have the fan acting opposite the direction of motion. Okay? So the fan is actually trying to push it back down the ramp. Okay? Now, to calculate work, work is F parallel times the displacement. And work can be positive or negative. Well, if the force is in the direction of displacement, work is positive. If the force is opposite the displacement, it's negative. So let's take a look here. The fan force is down, but it's moving up. So the fan is doing negative work. Okay? Gravity is down, and the box moves up. So gravity is also doing negative work, right? So we can highlight our displacements in blue. So we have displacement in this direction, right, which is exactly opposite the fan direction. And then we have displacement going up. The vertical component of displacement is 1 meter, and that's acting directly opposite of the gravitational force. So if we're going to calculate the work done by the fan, right, then we'd have to multiply the fan force times the displacement. Well, the fan force acts over a distance of 4 meters. So it'll be fan force times 4.0 meters. Okay. The gravitational force acts over the course of 1 meter. So we multiply that times a displacement of 1.0 meters. And the normal force is perpendicular to the direction of motion, right? And since it's perpendicular to the direction of motion, it does not do any work at all. So let's do the math here. We have 4.0 multiplied by the force of the fan, which is 0.5, right? And like we said, that force is opposite the direction of motion, so that's negative work. And then we also have, we have to include the force of gravity, which is mg. M is 0.5 and g is 10, right? And so 0.5 times 10 will give us mg. This is mg. And then we multiply that by 1.0, and that gives us a total of 5 times 1. That would be 5 joules. Okay, but again, it would be negative because gravity is going down and the box is going up. So gravity is doing a negative work on the box. It's taking away energy. Well, this is 2 and this is 5, and that adds up to -7. So that's the total amount of work. The fan's doing negative work and gravity is doing negative work as well.